Okay, so I want you to notice a few things that we did in the past couple of videos as we lead up to this final video for the day. First, we had to decide when we were working with data in our applications, we had to decide whether we were going to work in a connected or a disconnected manner from the database. And that would drive which path that we took within ADO.NET 2.0. If we picked connected, then we had to work with data in a very non-object oriented way. In other words, we had to work with data using an array element syntax with no strongly typed benefit and no benefit from IntelliSense, and we had to use the brackets and the zeros and ones and things of that nature. Okay, if we picked disconnected, then we could gain the benefits of the data being represented to us as strongly typed whenever we created a data set schema definition, as we did previously. But what about only working with a subset of the data within the database? The simple examples that I demonstrated in the previous video, we saw basically all the rows of data being pulled back from the database into an in-memory representation of the database, the data set. If we wanted to pull back only a smaller set of data to improve performance of the application, because remember, we might be pulling this data across a network connection from a database that's shared by dozens or hundreds of people simultaneously. So to accomplish that, which I didn't demonstrate, we'd have to go through a lot more work to configure the data adapter's commands. In fact, we might have to do so much work that it might seem that while our simple scenarios made a lot of sense, the more advanced scenarios just make using a data set in this regard rather difficult, to say the least. But still, we could work with the data in a very strongly typed, object-oriented sort of way, and that was a big step forward for us. So, thinking back to how we can refine our search results, we were using Transact SQL there earlier in the day and yesterday. T-SQL was really efficient at finding exactly the rows of data that we wanted to work with. We could use that where clause and pile on several different where clauses so that we could get a very small subset of data to find specifically the data that we needed to view or change in some way. And the reason is because T-SQL, the language, was created specifically for the purpose of working with sets of data. Using a more object-based approach, sure, we have a few ways we can navigate through a collection of objects. We can iterate through them and just do an if statement and keep searching to find, does this meet this condition? But it's not nearly as robust as Transact SQL. If we have to loop through every record and we have 10,000 records in memory, you can see where that would take a long time. Whereas with Transact SQL, it's able to narrow down and only select the 5 records that we might want to work with. Okay, so there's kind of this disconnect again between the utility and the function of Transact SQL, but our desire to work with the data in an object-oriented way, and they call that sometimes an impedance mismatch in engineering. So what if we could treat collections of objects or rows of data or anything that you would consider a grouping of data that we would normally work with and manage, and have a single unified syntax that allows us to work with sets of data no matter whether that set was an array of data or a collection of objects or rows of data in a database or working with an XML file or an XML document, anything you can possibly manage. What if we had a single syntax that allowed us to do that and gain the benefits of it still being object-oriented and yet being able to refine and search for things very efficiently? And so that is the purpose of a technology that was introduced in 2005 called LINQ, L-I-N-Q. And we're going to demonstrate how to use a specific brand of LINQ called LINQ to Entities in this video. And I want you just to follow along and observe. I'm only doing this for one reason, just to demonstrate how simple the process of working with LINQ to Entities is compared to or as a progression of thought from what we were looking at in the previous videos. So what we'll do in days 9 and 10 is get a handle on LINQ, specifically LINQ to objects and LINQ to entities. Don't worry if you don't know what that means just yet. We'll get there. I'm only providing this video for the sake of comparison to demonstrate how things have progressed since ADO.NET 2.0. I just want to impress on you the fundamental shift that Microsoft made when it introduced LINQ, and for our purposes, LINQ to entities. Okay, so to illustrate this, I have a brand new project called ADONet 4 LINQ to entities. All right, and the first thing that I want to do is pull over a compact edition database from a previous example. So I'm going to select Add Existing Item, and I'm going to go to this ADONet 2 Connected Compact, and I'm going to change and only look for data files and grab the database one and click Add. If you've been following along, this should work. You should be able to find that on your within your directory on your My Documents. So just to kind of reiterate, My Documents, Visual Studio 2010 projects, and hopefully you have a list of projects like I do if you've been following along. Okay, but at any rate, as we've seen in previous videos, a data source configuration wizard pops up. We've chosen the data set in the past. This time we're going to select Entity Data Model and click Next. And it asks, where should we get the model from? We're going to generate it from the database. Click Next. And there are some options here. I'm not going to change any of these options. I'm going to leave them as the defaults. These we'll discuss at a later date. Okay, so now it's looking through the database, and all I want to do is select the tables. There's only one table, customers. Later in this video, we're going to add a second table to show how to work with relationships with LINQ. And then I'm going to click the Finish button. Now what happens here is going to look an awful lot like what we saw in the previous video when we were working with generated data set schema definition, in so much that we have this visual designer and we can see an entity here called customer, and we can see all the properties of customer, and this is an object, but it represents the table called customers in our database and the fields or the columns of that table in our database. But I'm going to save this for now. And then I'm going to come over to my program.cs file, and here let's go ahead and unpin that. And so similar to what we did previously, I am going to need to do a little bit of work. This time I'm going to create an instance of this model called database1 entities. I'm just going to call it DE. I could call it context or something like that, which might be a little more descriptive, but we'll leave it as DE for right now. Now this is going to look really strange to you. It's going to look like an amalgamation of C# and SQL. Here we go. Okay, so this is probably the line of code that is going to make you want to scratch your head. There are no double quotes, so this is not Transact SQL. This is LINQ code. And essentially what we're saying is, for this entity from our model, search for those instances of that entity where the customer ID equals 1 and return that. And now we're going to save it in a collection of objects called customers. Now we're going to work with customers, take the first instance of the customer entity and return its first name and print it out to screen. So let's run the application. Okay. Awesome. Now you might be thinking to yourself, okay, well, clearly the secret sauce here is this model1.edmx file. It's probably a lot like the dataset schema definition, and it created behind the scenes, you know, the select, the insert, the update, and the delete statements, SQL statements. That's not exactly what's going on here. This query that we've written, when it gets compiled and run, it will generate the Transact SQL on the fly, meaning that C# or the LINQ interpreter to the entity model will actually generate transact SQL on the fly based on the complexity of the query that we've created, and then pass that transact SQL command to the database to be executed. Okay, so there's a nuance here. It doesn't figure out this in advance. That's what makes it so flexible, and what made the data set schema definition inflexible, and what required so much upfront configuration. This time, it's all done on the fly, and it's done quickly and efficiently. Okay, and we're going to make more of a, we're going to elaborate on that a little bit more in days 9 and 10. So just stay with me for a moment. Let's create a more complex example. To do this, what I want to do is open up our database, database1.sdf, and I'm going to look at the tables, and I want to add a second table, and then I want to create a relationship between the customer table and a new order table. So if you want to follow along, just right-click on Tables in the Database Explorer and select Create Table. We're going to call this Orders. So we're going to make it an identity column. It will not allow nulls, it will be unique, and it will be the primary key. Order date will be just a date time. Order amount will be a money. And then we need a foreign key called customer ID, which will relate this back to our customer table. Okay, so now I'm going to click OK to save this. And then I want to create a relationship between these two tables. So I'm going to right-click and select Table Properties. I'm going to go to Add Relations. I'm going to create Customer Orders. The primary key will be customer ID, and the foreign key table will be order customer ID. We'll click Add Columns, Add Relation, and then finally click OK to create the relationship. Now I'm going to right-click and select Show Table Data, and here I'm going to do just something like January 1st, 2010, order amount 100, customer ID 1. We should have a customer ID of 1 and 2. So 1, 2, 2010, we'll go 150 by customer 2. Then on the 3rd, we'll do 125 by customer 1. And then 175 for customer 2. And then finally, we'll go 200 and go customer 2 as well on that one. Okay, so now we have some data in our database. Pause the video if you need to catch up. The data itself isn't as important as the fact that you're able to create that relationship. Okay, so now what I'm going to do is go back to my model.edmx file, and I'm actually going to delete this. I do have some other options here, but for right now, for simplicity's sake, I'm just going to delete it. That's going to give you some errors in your code. You're not going to be able to compile it just yet. But what we can do is we're going to go up to our data and select Add New Data Source. And we're going to select where will we get the application get its data from? A database. And then click Next. And now it'll start looking similar to what you've seen previously. We're going to select Entity Data Model. We're going to generate it from the database. We could use the previous connection, but instead we're going to just let it create a new one. Now we're going to make sure to select all tables and click Finish. This time we'll see that we have the customer, and there's a line between customer and order, meaning that one customer will have potentially multiple orders. And that's exactly the relationship that we want. Notice also there's something called navigation property that gives customer access to orders. And for any order, it gives it access back to a customer, which makes sense, right? So now let's go back to our program.cs. We're going to have to rename this. Let's see what we need to call it. Database 1, entities 1. Okay, because we made a change to the name when we deleted the old entity model and created it again. Okay, so let's first of all see if this example still runs, and it should, and it does. But let's get a little crazy with this example now. Let's first of all look for those customers where the order amount is greater than 150. So give me any customers who have ordered more than $150 worth of product on any given order. Let's run the application. And now we only bring back one person. One, because if we look at our data, the customer Bob, customer ID number 1, he never ordered over $150 in merchandise. So we're able to write this query. This query gets analyzed, turned into Transact SQL, sent to the database. The data is returned, and now we get to work with it in a very object-oriented sort of way. Let's have some more fun. Because this is object-oriented, we can do some other cool stuff like this. Tell me then, or let's do this instead. What's that var keyword? We'll talk about that later too. I'll tell you what, let's go last name this time. Okay, let's run that. So now, customer Jaworski had 3 orders in our database. We can even do something like this. Go ahead and print out each of those orders. All right, so those are the dates and the amounts of the orders. All right, and we can continue to go on from here, but I think that that pretty much proves the point that we want to get across, and that is the flexibility that we have by writing a SQL-like syntax to work with a collection of data, to refine that collection of data, that the actual way that that gets implemented is up to the LINQ provider. In the case of LINQ to entities, that provider generates Transact SQL. In the case of LINQ to Amazon, it would generate the appropriate API commands to talk to Amazon. In the case of LINQ to XML, behind the scenes, it's working with an XML document DOM to determine the best way to pull the piece of information that it needs. In the case of LINQ to objects, it works with some internal collection objects to find and use the best way to search for the data. But at any rate, we just express intent, what we want to happen, and then we allow whatever brand or version of LINQ the provider will actually figure out the best way to return that data to us, and we don't have to worry about it. But again, we get the benefit of the Transat SQL precision using the where clause, and we also get the benefit of working with the data in a very strongly typed, object-oriented sort of way. So once again, let me reiterate that one of the big benefits of LINQ is when you learn it for SQL or learn it for objects, then you're going to know it for every other usage, like LINQ to XML or LINQ to Amazon, or other neat ways that LINQ has been used by both Microsoft and by third parties. It's knowledge that you can leverage every time you sit down to work with groups or collections of data, regardless of what form they're in. So this is a huge innovation because as a developer, it dramatically reduces what you need to know before you can become productive. Just learn LINQ inside and out, and you can apply it virtually everywhere. Okay, so that's enough for day 8. I probably overwhelmed you with the number of ways that you can access data from the database, and we only covered a subset. We're going to explore LINQ now for the next 2 days and make that really the focal point for our data access from this point on. So you can somewhat purge some of that ADO.NET 2. Stuff from your memory, although I think that having that background is really going to benefit you in the long run. So there's several concepts that LINQ relies on heavily that unfortunately we are only going to be able to address at a very superfluous level, but for more information there's a series on just C# 3.0. It's a new language series, new improvements to the language, and you can watch for more information if what I cover in the next day or two isn't enough for you. So, okay, at any rate, that concludes today. We have a quick exercise that you should go through to become more familiar with these concepts, and then we can move on to LINQ. So thank you. See you in the next video.